If you have a set of long lat values that you want to convert to UTMs or vice versa, here's an easy trick. First, download and install Google Earth Pro on your computer if you haven't already. Next, make sure that Google Earth Pro is set to the same coordinate system as your waypoint values. Click on Tools, then on Options. Here I'll assume that your list of waypoints is in degrees, minutes, and seconds. Create a place mark more or less where the actual waypoint is. Give your waypoint a name and edit the long lat values to match your waypoint exactly. When you change the values, the place mark will jump to the correct position. If you wish, you can add comments and change the symbol and symbol color. Click on OK to save the place mark. Actually, you should enter all the waypoints for your hike, but here I'll use a single waypoint as an example. Go back to the Google Earth Pro settings and this time select the coordinate system you want to hike with. Here I'll assume that you want to convert your long lat values to UTMs. Hit OK to close that dialog box. Right-click on the symbol for your waypoint and choose Properties. The values are now in UTMs. You can create a bunch of points using one coordinate system, change the settings, and Google Earth Pro will recalculate all the position values for you. There are other ways to do this, but Google Earth Pro is free, and you also get to compare your waypoints to the local terrain. Google Earth Pro's coordinate systems are based on a single datum, WGS84, which means you can only use it safely to convert waypoints based on that system or NAD83. If you need to change datums, you need to use other software. I use Garmin Basecamp on my PC to communicate with my GPS. In Basecamp, I can select an initial coordinate system and datum, then enter the points based on that system and datum. Then I can change the settings to a different datum, or to a different coordinate type, or both. When I reopen a given waypoint, it'll display the location using the new setting and datum. If you use different map software, dive into the settings and you can probably play the same game. You may also be able to play the settings game right on your GPS. Let's talk about one last thing, precision versus accuracy. Earlier in this video series, you saw these UTM values for the high point on a mesa in New Mexico. The location is stated to the nearest hundredth of a meter. That means that the precision of the measurement is to the nearest centimeter. But does that mean that the accuracy of the measurement is to the nearest centimeter? Absolutely not. If you're using a handheld GPS, your reading could be several meters away from the actual location. If you're having trouble understanding the difference between precision and accuracy, this example may help. Let's say you shoot an arrow and it misses the target by exactly 1 meter. That's about 3 feet. If you want to be extremely precise, you miss the target by 3.28084 feet. Very precise. But does that level of precision mean anything? Of course it doesn't. When your goal is to hit a target, accuracy is what counts, not precision. And even if a hiker's GPS unit states your position to the nearest meter, that's precision, not accuracy. If you set your GPS to the wrong datum, your problem is accuracy, not precision. I'll provide a concrete example. Here are 10 readings from my GPS of the exact same spot in my backyard, spaced over a couple of days. When you look at the readings, they're spread around in an oval that measures 7 meters east-west by 15 meters north-south. So the readings from my handheld GPS is precise to the nearest meter, but it's only accurate to about 5 to 10 meters. I can't blame the results on my GPS unit. A lot of factors affect the accuracy of GPS readings, and which GPS you use is only one of them. In any case, getting within 10 meters of my intended position is all I need. I recommend repeating this exercise for yourself. Take a bunch of readings at the exact same spot spread over several days and see how tightly they plot. That'll give you a sense of the practical limits of GPS navigation. That's it for coordinate systems, I hope. But if anybody has questions, please let me know in the comments. If I can't provide a simple answer, I may add a video to go over the question.